Dear colleagues, I'd like to greet you. I'm Dr. Aleksandar Petrovski from the Faculty of Architecture in Skopje in Macedonia, and together with Professor Dr. Aleksandar Gjerasimovski from the Faculty of Technical Sciences in Serbia, we wrote the paper Sustainability Assessment Methods for Improvement of Indoor Air Quality, which I will be presenting to you today. Humans spend almost 90% of their time indoor, and in certain countries the indoor air can be more polluted than the outdoor air. The improvement of the airtightness of buildings due to energy efficiency demands increases the problem of CO2 concentration in the indoor air. According to some studies, the indoor air can be up to 5 times more polluted than the outdoor air. Also, building materials are the main sources of volatile organic compounds and other pollutants, and there are various materials and building components which we use, such as wood-based materials, fiberboards, and so on, which emit various pollutants. Studies show that the indoor environmental quality can play an important role in work performance, in the productivity and the health of building users. Therefore, indoor air quality is one of the essential criteria for evaluating the quality of a building, according to the US Environmental Protection Agency. There are several sustainability assessment methodologies which assist architects and engineers to evaluate in a fast manner the quality of the indoor air. Therefore, this paper investigates the harmful compounds which are related to common building products, and further, there are several sustainability assessment methodologies are examined, such as LEED, BREEAM, and others. And also novel sustainable material certification systems were examined, such as the Declare label, which allows manufacturers of sustainable and non-toxic materials to be transparent in their ingredients and more visible to the broader construction market. These assessment methodologies evaluate the building's performance or building materials regarding the indoor air quality according to a given set of criteria, while they take into account the building materials. The aim of this paper is to investigate the criteria which are considered in the formation methodologies during the building assessment process. The indoor air may contain a variety of contaminants, including particulate matter, tobacco smoke, radon, biological contaminants, and more than 400 organic and inorganic chemical compounds, all of which have associated health effects on humans. Additionally, indoor air pollutants can reach concentrations of up to 10 times their levels in outdoor air, regardless of the building location. Such pollutants are emitted by indoor activities, for example, cooking and cleaning, from products or materials, such as furnishings and various building components, and also the internal atmosphere is as an extension of the external environment. Therefore, the outdoor air quality impacts the indoor air quality, and the CO2, CO or SO2 and so on quickly deplete indoors. The analysis which we carried out identified harmful compounds which correlate to certain groups of construction materials. Hence, the formaldehyde compound is identified in wood panels, adhesives, resins, particle boards, and other types of wood products. These can cause serious health issues such as irritation, asthma, and even worse. The BTEX compound is also found in wood-based materials and particle boards, as well as in paint, laminate, and furniture products. This compound is correlated with serious health issues such as anemia, damage of vital organs, cancer, and so on. The phthalates are found in paints, in plastics, in vinyl floor, and even in wall coverings. While the health issues that arise are problems with reproductivity, hormone problems, and so on. The terpenes are found in wood-based materials and cause irritation, while the chlorinated compounds are found in PVC polymers, causing irritation and being possibly carcinogenic. Also, energy-efficient buildings require a large amount of insulation. However, thermal insulation comprising chemicals can have harmful emissions and can cause health issues. Considering that many insulation materials are organic based, there can be residual harmful chemicals that are not polymerized and can be emitted indoors, thus decreasing the air quality. For example, TVOCs were mostly found in phenol formaldehyde insulation and EPS, expanded polystyrene, while to a much lower degree in extruded polystyrene and PR insulation. Harmful chemical group classes were identified in certain groups of construction materials and the health issues that they cause, which were grouped in several categories. They were based, they were analyzed actually regarding where they are most commonly found, such as in various construction materials and furniture, and therefore different kinds of products were investigated. The analysis of pollutants in relation to the type of space in a building is also carried out, and also regarding the activities in that certain space. And therefore, the pollutants are classified according to the room type in a conventional residential building, where they are most commonly found. Where in the garages and the basement we mostly have CO, mold, radon from the soil, and so on. In the kitchen, there are most commonly are the CO, NO2, PMs, PM particles. In the living areas, there are VOCs, formaldehydes from carpets, paints. There's tobacco smoke, NO2 from wooden stoves, air fresheners, and so on. In the attic, we can find most commonly dust, formaldehyde, textile fibers, asbestos, even, and so on. Further, the comparison of several sustainability assessment methodologies such as LEED, BREEAM, gave significant insight regarding inclusion of indoor air quality criteria. For example, in BREEAM there are 5 categories in the guidance which are considered as a minimum. And there is a need for air quality plan and documentation for the building. In the LEED standard, there are 2 options for assessing the indoor air quality which can be implemented after the construction ends and the building has been completely cleaned, where the first option is flush out before or during occupancy, and the second option is air testing, in which the maximum concentration levels are prescribed along with the contaminant and the testing method. The well method mostly focuses on PM particles, VOCs, ozone, and the living building challenge standard is being the strictest in meeting a healthy indoor air quality and eliminating toxic and hazardous chemical groups. Studies show that the average contribution of indoor air quality to green building schemes worldwide is 7.5%. There are 2 steps in the review procedure, which are shown in the upper picture. In step 1, the objectives are to analyze how and to what extent indoor air quality is taken into account in green building certification. In step 2, a detailed analysis is carried out, which focuses on indoor air quality management. Depending on whether the facility is new or renovated or it's already existing, the council sets different requirements for air quality monitoring. So we will divide buildings into 2 groups. The first group is newly built or renovated. The second group is already occupied for more than a year. Monitoring air quality can earn 2 points in the assessment scheme for new buildings or if they're renovated. Fully operational buildings, or those which are occupied for more than a year, are evaluated according to the LEED operations and maintenance rating system. The building owners should conduct a yearly occupant satisfaction review and air quality evaluation, and based on these rates, the human experience score is calculated and adds up to a maximum of 20 points. Also, there in those 20 points, the occupant satisfaction score has a weight of 50%, and the remaining 25% are divided regarding CO2 or TVOC score. I would like to mention the Declare label, which is a voluntary self-disclosure program for certifying construction material products. The Declare label contains the red list, which is a list of banned compounds and the product ingredients which must comply to and which must be omitted from the materials or components which are used in the building. Each ingredient must be reported with its chemical name and its CASRN number, CASRN, and the percentage of each ingredient in regard to the finished product. The red list represents the worst in-class materials, chemicals, and elements which pose serious risk to human health and to the ecosystem overall. And they get updated, this list gets updated throughout the years. The current list includes 22 chemical groups represented by over 800 individual CASRNs. The specific CASRN list was created in collaboration with the Healthy Building Network and the Pharos Chemical and Materials Library, and in order to be certified as a sustainable building according to the Living Building Challenge standard, the building should not have any of the red list components. In the analysis of the red list compounds, we structured them according to which construction materials are most commonly found, and they were summarized in a research paper. However, there are some exceptions, such as phenol formaldehyde, which is allowed in composite structural members, or glulam beams, or rigid mineral wood insulation. So there are some exceptions of these compounds. Next, there are possible substitutions which need to be considered for materials which have toxic emissions. For example, the PVC can be replaced with bio-based plastics. Certain companies put efforts in removing heavy metals in their products. By using materials such as concrete and recycled tile, it is possible to significantly reduce the amount of formaldehyde concentration in a home. We can also use salvaged wood, reused wood, for products which are certified with the Forest Stewardship Council certification label. However, another issue is that new chemicals are introduced into the marketplace with little to no testing, which pose health issues. Therefore, we have an area of concern such as the nanomaterials. Also, antimicrobials, which are used in paint to inhibit mold, which is applied in carpets and other materials. Epoxy resin is the primary compound which is used to make epoxy paint coatings, adhesives, and has two chemicals which cause concern. And study shows that nanoparticles may have toxic properties, and scientific communities call for more regulated testing and assessment of the emerging nanomaterials field. As a conclusion, I would like to mention that this research examines sustainability assessment methodologies for buildings in terms of how they assess the indoor air quality. Also, the analysis which was carried out was regarding harmful compounds correlated with certain construction materials which are most commonly used in buildings, and which are correlated also to the type of building space, mostly in residential buildings. From the research, it can be concluded that the sustainability assessment methodologies which are most commonly used take to a certain extent the indoor air quality in their assessment with different criteria and quality demands. It can be noted that the Living Building Challenge standard is the most has the red list, and has the most difficult criteria to be met in the assessment compared to other methodologies. Due to the large array of pollutants which are present in the building's indoor air, regular air quality monitoring is recommended for the building owners, as it guarantees constant monitoring of the occupants' well-being and the opportunity to take immediate actions on improving air quality, if the monitoring system especially is integrated with the HVAC system. Future research is required on new and healthy materials as sustainable substitutions for conventional toxic materials which emit harmful pollutants in the indoor environment. I'd like to thank you all for your attention and hope to meet you all on some other occasion. Thank you very much.